In example 5, we're again asked to simplify expression to one term. We have sine cubed x plus sine x cosine squared x. Here we can start to think about what could we factor out that's common. We see sine x and sine x is common, so we could write this as sine x times sine squared x gives us sine cube x plus cosine squared x. Sine x times this gives us sine cubed x. Sine x times this gives us sine x cosine squared x. Well, we know our Pythagorean identity. Here's the first one. Sine squared x plus cosine squared x equals 1. This is our Pythagorean identity, the one we started with from our Pythagorean theorem. Which means anytime I see sine squared x plus cosine squared x, as I do here, I can substitute 1. So our problem becomes sine x times 1, which is sine x, because I substitute that for 1. And we get sine x times 1 is sine x. Now we're getting a little more complicated. We're asked to simplify this to one term. Well, not many options here, so let's FOIL the numerator. These are conjugates, so we know the oi of FOIL is going to go away. Cosecant times cosecant is cosecant squared x plus cosecant x minus cosecant x. That goes away. This times that, the last terms are going to give us minus 1 over cosine squared x. We might be stuck here thinking, what are we going to do? Are we going to divide this and this into that? We could try that. Or we could recognize that we have an identity, which is cotangent squared x plus 1 is equal to cosecant squared x. That's one of our Pythagorean identities that I asked you to memorize. So anytime we see cosecant squared x, we can write this. So I'm going to substitute for this, and this problem becomes cotangent squared x plus 1 minus 1 over cosine squared x. I've substituted this for this right here. And you can see I could write in that in parentheses, but I know my next step is going to be plus 1 minus 1 gives us cotangent squared x over cosine squared x. We're getting closer to our goal of simplifying to one term. By definition now, cotangent squared x is cosine squared x over sine squared x, and that's all divided by this cosine squared x. I'm going to put this over 1. Now I do keep, change, flip. Cosine squared x divided by sine squared x times, we have to flip this one, 1 over cosine squared x. Now we can see these are going to cancel, leaving us with 1 over sine squared x. If you know your reciprocal identities, that is cosecant squared x. And we have in fact done it. Take a look at this one again. It's a little bit complicated, and it involves recognizing that anytime we have cosecant squared, we can substitute in cotangent squared plus 1 and then simplify. Here is a more complicated problem. It just asked us to simplify this. Often when we have two fractions, what we want to do as a first step is write them over a common denominator. Well, there's not much common here, so let's mash them together. 1 plus secant x times tangent x. Now I ask myself, 1 plus secant x times what gives us a common denominator? Times tangent x. So I have to multiply the numerator by tangent x as well, and that gives us tangent squared x plus tangent x times what gives us this denominator? Times 1 plus secant x. So I have 1 plus secant x from the numerator times this again, 1 plus secant x. This times 1 plus secant x, whatever I do to the denominator, I must do to the numerator. Now, let's FOIL that. We have tangent squared x plus 1 times 1 is 1. Secant x plus secant x gives us plus 2 secant x plus secant squared x all over 1 plus secant x times tangent x. And what we can recognize here now, we know from our Pythagorean identity to the side is that tangent squared x plus 1 is secant squared x. So we can make a substitution there and get secant squared x plus 2 secant x plus secant squared x all over 1 plus secant x tangent x. So far, that's what we have there. Now, what we're going to do is we're going to combine these two and get 2 secant squared x plus 2 secant x over 1 plus secant x times tangent x. Now you see what's common to both of them in the numerator, both terms in the numerator, if you let me come up here, is secant x. Well, we actually have 2 secant x. 2 secant x leaves us with secant x plus 1. And we're over this denominator of tangent x times, I'm going to write this as secant x plus 1. The reason I do that is so you can see now that these will cancel, and we're left with 2 secant x over tangent x. And we're asked to simplify this more. At this point, I would go to the definition of secant. This is 2, 1 over cosine x over sine x over cosine x. We're going to see this keep, change, flip a lot. This is 2 times 1 over cosine x, change division to multiplication, and now we have to flip this. Cosine x over sine x, cancel, cancel, gives us 2 over sine x, which is 2 times 1 over sine x, which of course is 2 cosecant x, and we've simplified as far as we can. In example 8, we see a similar process to what we did in the last example. When you have two fractions, what we often want to do is to combine them as one fraction. Now they don't have much in common, so let's mash them together. 1 minus sine x times cosine x. Now when you do common denominators, you have to ask this question. 1 minus sine x times what? Times cosine x. So you better multiply the numerator by the same thing. Cosine x times cosine x is cosine squared x. And cosine x times what? Times 1 minus sine x. So minus sine x from our numerator times what's missing? Cosine x times 1 minus sine x. Not many options here except to distribute. Cosine squared x minus sine x plus sine squared x all over 1 minus sine x times cosine x. Now, recognize here that we're setting up an identity. We do know that cosine squared x plus sine squared x equals 1. So if we could ever find cosine squared x plus sine squared x, we can substitute 1. Well, let's move this guy over. Cosine squared x plus sine squared x minus sine x. I've reorganized the numerator over 1 minus sine x times cosine x. Now, look here. This is 1. Cosine squared x plus sine squared is 1. So 1 minus sine x. I've replaced this with 1 over 1 minus sine x cosine x. Now take a look here. This, if we consider this one term, one term cancels with one term, which will leave us with 1 over cosine x, which of course is secant x. And there it is, simplified. All right, we've done a lot, and I know I've gone fast. You can pause the tape and go back and look at it. If you're confused, I will refer you to the identities. If you don't know your identities well, you really can't do this, and you certainly can't do it fast. I know you're like Bambi on the ice. You're not sure of yourself yet. Well, you'll get there. And what will make that ice solid under your foot to give you solid footing is knowing your identities well. You've got to know those like you know your ABCs. Give that to me, and you have yourself a wonderful afternoon. Thank you very much for paying attention.